Your RAG system generates an answer. The retrieval was good. The prompt was well written. But the answer only addresses half the question and misses a key detail that was actually present in one of the retrieved chunks. A self-reflection loop catches this before the user sees it. The model reads its own answer, identifies what is missing, and decides whether to try again with a more targeted approach. There are 3 common cases where a single generation pass falls short. Multi-part questions where the model answers the first part and forgets the second. Ambiguous questions where the model picks one interpretation without acknowledging the other. And rich context chunks where the model skips a relevant detail because it latched onto a different part of the text. Reflection adds a verification step that checks whether the answer is complete and flags specific gaps for a targeted second pass. The reflection loop has 6 steps. Generate an initial answer, then critique it against the original question. If the critique determines the answer is complete, return it immediately. If not, the critique identifies the specific missing aspect and frames it as a new retrieval query. We retrieve again using that focused query, combine the new chunks with the original context, and regenerate a more complete answer. The loop runs until the critique is satisfied or a maximum iteration limit is reached. The critique prompt is the heart of the reflection loop. We instruct the model to act as a strict answer reviewer and compare the answer against the original question. The response format is constrained to either the word pass or the word fail, followed by the missing aspect phrased as a search query. Constraining the output format is critical. A free-form critique is difficult to parse reliably. A binary pass or fail with a structured suffix is easy to split and route programmatically. The critique chain pipes the prompt through the language model and a string output parser. The parse critique function splits the result. If it starts with pass, we return true and no missing query. If it starts with fail, we split on the colon and extract the missing aspect as a string. That string becomes the retrieval query for the second pass. Temperature 0 on the critique model ensures the decision is deterministic and not affected by sampling randomness. The first part of the reflection loop sets up the initial state. We retrieve documents for the original question, generate a first answer, and store all retrieved documents in a list. We track the iteration count so we can enforce the maximum iteration limit. Accumulating all documents across iterations in one list means each regeneration has access to everything retrieved so far, not just the most recent search. The second part runs the critique loop. On each iteration, we run the critique chain, parse the result, and break if the critique passes. On a fail, we use the missing aspect as a new retrieval query, extend our document list with the new results, reformat the combined context, and regenerate the answer. The loop continues until the critique passes or we hit the maximum iteration limit. Returning the final answer after the loop ensures we always return something even if the limit is reached. Testing with a 2-part question shows the loop in action. The first generation answers the physical refund policy correctly, but ignores the digital products part. The critique returns fail with digital products return policy as the missing query. The second iteration retrieves digital policy chunks, regenerates with the combined context, and the critique returns pass. The final answer covers both parts completely. The loop ran twice and stopped as soon as the critique was satisfied. You now have a self-reflection loop that generates an initial answer, critiques it against the original question, retrieves additional context for any identified gaps, and regenerates until the critique passes or the iteration limit is reached. In the next episode, we move to GraphRAG, a fundamentally different approach to knowledge representation that uses entity extraction and knowledge graphs to capture relationships between concepts that chunk-based retrieval cannot express. Subscribe so you do not miss it. See you in the next one.